Okay, dear engineering aspirants and students preparing for your JEE Advanced, not for main. Let us go and solve another numerical problem from engineering mechanics. Problem set 2.3, solution 2.34, and the statement of the problem runs like this. In figure M, as you can see it here, weights P and Q, there are two weights P and Q are suspended in a vertical plane. This P and Q, they are suspended vertically from top to down. In a vertical plane by strings 1, 2 and 3. This part from here to here is string 1, from here to here is string 2, from here to here is string 3. Here is a support point, here is a support point D. As shown in figure M, find the tension induced in each string if P is equal to 30 kilonewton, Q is equal to 40 kilonewton, alpha is equal to 40 degree and beta is equal to 50 degree. And also find the inclination gamma of the segment CD to the vertical, means what angle the CD makes with the vertical. Now, if you look at the diagram, since A, B, B, C, C, D are strings, so the axial force will be a tension force. In the part AB, let it be S1. For the point B, it will be to this side, and for the point A, it will be to this side. Same S1. And for the part BC, let the tension be S2. If you look at the point B, it will be away from the point B, it will be S2. And if you consider point C, it will be to this side, S2. And for this part CD, let the tension be S3. So for the point C, it will be away from the point C, let it be S3. If you consider this point, it will be to this side, S3. And this is alpha, this is beta, this is gamma. Now we can apply Lamy's theorem here, we can apply Lamy's theorem here. At here there are three forces, S1, the load P, and the tension S2. So we'll be required to find this angle from here to here. Now since this angle is beta, this angle is alpha, this is vertically down, so this angle is also alpha. Now, so what is given, I have just explained. P is given as 30 kilonewton, Q 40 kilonewton, alpha 40 degree, beta 50 degree. We have to find the tension S1 in the part AB, S2 in the part BC, and S3 in the part CD, and I also have to find the angle gamma. I have redrawn the diagram for you at point B, where there are three concurrent forces. At point B, there are three concurrent forces. S1 to this side, here is your S1 to this side. S2 is to this side, which I have shown it here. S2 is to this side. The weight P, the load P to this side. And just I explained this angle is alpha, alternate to this angle. So this is your alpha. Now let us apply, since it is in equilibrium, I mean the sigma F, sum of the forces at point B is 0. So let us apply Lamy's theorem. P over sine of this angle. This is to be understood. P over sine of this angle from here to here. Now interestingly, how much will be that? This angle, how much will be this? So let me start from here. I am adding alpha, beta, which I will subtract later on. From here to here is 180 degree. I have added an extra angle beta, so which I will subtract. This is 180. This is alpha. So 180 plus alpha. This extra angle added, so I have to subtract it. So sine 180 plus alpha minus beta is your this green part. this part, right? Over is equal to S1 over sine of this angle, that is sine beta, is equal to S2 over sine of this angle. This is equal to 180 minus alpha. That's all. Then we proceed gradually to solve the new problems. So if you consider these two equalities, P over this is equal to S1 over sine beta, and if you cross multiply, if you take these two and cross multiply, you get S1 is equal to P sine beta over sine 180 plus alpha minus beta. Value of P is given 30 kilonewton, beta is given 50 degree, sine alpha is given, beta is given. Just I have put the values here, and using a scientific calculator, if you put it properly, this comes out to be 132.3442 kilonewton, right? Then again, if you consider these two, if you consider this fraction equal to this fraction, because they are equal, and cross multiply, you get S2. So by cross multiplying, you get S2 is equal to P sine 180 minus alpha over sine of 180 plus alpha minus beta. And just put the value of P alpha beta, then you get this. And use it in a scientific calculator, you get S2 as 111.0499 kilonewton, the second answer. So S1 is found out, S2 is found out. Now let us go back to the other point of equilibrium, that is the point C in the diagram where you can apply Lami's theorem. That is the point C. There is a load Q, there is S3, there is S2. So at point C, so let us apply the Lami's theorem. I have redrawn the diagram at point C to apply Lami's theorem. Point C, to this side is S3, this side is Q, this side is S2. Now the question is how this angle is beta. How this angle is beta. So let me show you the original diagram. This is hanging vertically downward, this is hanging vertically downward. So this is a straight line, this is a straight line, this is a transversal. So if this angle is beta, this is also beta, because alternate angle. So that is what I have shown here. So now it is pretty simple. So Q over sine of this angle, sine beta plus gamma, is equal to S2 over sine of this angle, that is 180 minus gamma, is equal to S3 over sine of this angle, and this is equal to 180 minus beta, right? So now if you consider, we have just found out the value of S2. We have just found out the value of S2. I am considering digits up to 2 decimals. So instead of writing 111.0499, I am writing it as 111.04 over sine 180 minus gamma. From trigonometry, same thing as sine gamma. I have put the value of Q 40, sine of beta value is put in, gamma is not known to be found out, right? Now just cross multiply. Now just cross multiply. 40 sine gamma is equal to 111.04 sine 50 plus gamma. This comes under trigonometry. Sine of A plus B is equal to sine A into sine A cos B plus cos 50 into sine B. Now this remains same thing as this. Put the value of sine 50 from a scientific calculator. This remains same thing as this. Put the value of cos 50 is this much. Now This factor is, this term is multiplied here, 1110.04. So bring it to the left hand side and divide, it will be divided by 40. So 40 divided by this gives you 0.36, sine gamma remains on sine gamma, and this remains as such. Now, a 0.36 sine gamma, here is 0.642 sine gamma. Bring this to the left hand side, so this becomes minus 0.282 sine gamma. We are left on the right hand side 0.766 cos gamma. Now, bring cos gamma to the left hand side, keep it below sine gamma, so it is divided, and take this was multiplied here, goes to the right hand side, is divided, but we have a negative number here. Sine gamma over cos gamma is tan gamma, so gamma is equal to tan inverse of minus 0.766 over 0.282. That, if you use a scientific calculator, comes out to be minus 69.4 degree 47 minutes of arc. Seconds of arc I have not considered here. So now is the interesting thing. Now, therefore the actual gamma, look how the gamma can be negative. So therefore the actual gamma is 180 plus gamma, that is 180 minus of 69 degree 47 minutes, that comes out to be 110 degree 13 minutes of arc. Now again, if you consider the equality, these two equalities, this with S3 over sine 180 minus beta. If you consider this equality and cross multiply, and then you get S3, the tension S3 in the segment CD. Q sine 180 minus beta over sine beta plus gamma, just put the value of Q and put the value of a beta, put the value of gamma which is just calculated. So this comes out to be 90.531 kilo Newton. Thank you.